Question 36 is the last question in the paper. So by the time you get to the end of the paper, sometimes you're feeling a little bit frazzled, and a question like this can be hard because there's quite a lot to read. Now, I haven't put the whole question on the board. I've just summarised the important bits and drawn the picture. Basically, we've got a fishing boat, F, which is going at 10 kilometres an hour, and it's left this port, which I've labelled P, and it's going at a bearing of 150 degrees. Now, as I read the question, if I see something important that's not on the diagram, I put it on. So 150 degrees means from north, we're going not just 90, but then another 60. And that makes this angle in here 60 degrees. There's a sailing boat, S, and it's heading at 20 kilometres an hour going west from an island. So it's going along like this. Now, both are leaving at midday. We need to find an expression for F and S. In other words, in terms of T, and that's time. And we need to show that X, which is the distance between the two boats at any one time, can be found with this expression here. Now, it's a show that question. So the good thing about that is that we've got the end point or the answer, but for the marks, we need to show the steps to get there. We've got one clue, which is that we need to start by finding expressions for F and S. So it makes sense to do that first. Now, on the diagram, F and S are just labelled as distances, but we need them in terms of T. So if we've got the speeds, what we need to do is turn those into distances. Now, if you are travelling at 10 kilometres an hour, how far have you gone after 1 hour? 10 kilometres, right? How far have you gone after 2 hours? 20. How far have you gone after 3 hours? 30. What am I doing to the number of hours each time? I'm just multiplying by 10. So how far would you have gone after T hours? 10T, 10T kilometres. That's how far you would have gone. So we have just made ourselves an expression for F, and we can write that down. F equals 10T. We were asked to find these expressions, so we should list them. And S, well, S is travelling at 20 kilometres per hour. So after 1 hour, it's gone 20 kilometres, 2 hours, 40, 3 hours, 60. So after T hours, it's gone 20T kilometres. And we can put that on our picture as well. The next step is to look at the diagram and consider what you know and what you need to know. You're trying to find this side here, X. Now you've got an expression for this side. You need an expression for this other side, and you've found this angle here. So now we need to find this length here, and we'll have ourselves a triangle to work with. Now, the question also states that the port and the island are 100 kilometres apart. So if you've found that this distance is 20t, then this distance in here in the triangle must be 100 minus 20t. So if it helps you, draw up just the information that you need here. You've got X, you've got your 60 degrees, and you've got 10t, and you've got 100 minus 20t. Now you've just got the information that you really need to find X. What rule do you need to find the length of a side if you've got a non-right angled triangle and you know two of the other sides and the included angle? The cosine rule. So the cosine rule says a squared equals b squared plus c squared minus 2bc cos a. And the important thing to know about this is the side that you're looking for, we need to consider that the other two sides, it doesn't matter which one is which for b and c, but the angle has to be the angle that's opposite the side you're looking for. So in that case, that's fine because we've got that. So subbing in what we've got here, x squared must be equal to 10t squared plus 100 minus 20t squared minus, now I'm just going to put everything in brackets here, 2 10t 100t, 100 minus 20t, and then we need cos A. Now cos of 60 degrees I can just put straight in. I could write cos 60 and then tidy it up on the next line, but I know that the cos of 60 is a half. Now putting that in there, I can see that my 2's are going to cancel here, so that helps. Now if x squared is equal to all of this, then we also know that x would be equal to the square root of everything. Now checking our solution, we know where we're going, and this is starting to look good. It's got a bunch of t's and t squareds, so it looks like the right way to go. So on the next line, let's say x equals, and put the whole thing underneath the square root, And let's expand brackets here where we can and see if we can tidy it up and get it looking like this. So 10t squared is 100t squared. Here we need to expand this out carefully, making sure we get the correct middle term. So we need 100 squared, that's 10,000. That looks like that's going to be the 10,000 that's in our answer, so that's good. We need to multiply the two terms together and double it. So that gives us minus, what's that, 4,000t. And then we need to square the second term, so that gives us plus 400t squared. And then over here we've got rid of our 2's, so we've got minus 10t that needs to be multiplied by both of these terms. So that gives us minus 1,000t. And I'm running out of space here, but I've got plus 200t squared, which ideally, if my line was a little bit longer, I'd fit on there. So now I've just got to tidy it up and double check. 100t squared plus 400t squared plus 200t squared, that will give me my 700t squared, so that looks good. And I've got minus 4,000t minus another 1,000, that gives me minus 5,000, which is also good. And I double check that's right, plus the 10,000. So I'm there. Now it's a show that question, so you won't get any marks for your actual last line, but you sort of need to finish with that last line to show that you did actually get it to where it needs to go. This question's worth 3 marks. So 1 mark would be for finding the expressions for f and s, and getting that 10t and that 20t. So that's quite simple for the first mark. The second mark would be for actually finding that you need to use the cosine rule and putting the right bits in. So the right bits would be working out that you needed that 100 minus 20t, because that was an extra thing that we needed to figure out. And we also needed to figure out that this angle was 60, so there was a little bit of work to do for the second mark, finding 2 of the parts and putting it all into that correct format. And then the third mark is actually for expanding out all the brackets and gathering up the terms and actually getting the right parts in your answer. So if you made a mistake expanding this out and you weren't getting these solutions down here, the good thing is you can see that it's wrong and you can look back and perhaps spot your own mistake. In part B, we need to find the time to the nearest minute when the distance between the two boats, x, is a minimum. Now, if you didn't get part A and you're just lost and weren't sure what to do, don't give up on part B, because part A was a show that question, so they actually give you what you need in part A to carry on and do part B. All right, now we need to make this expression a minimum. So if we were to graph this thing, it'd have a particular shape. To find a minimum is to find a minimum turning point or a stationary point. And to do that, we want to differentiate it. We want to let the first derivative equal 0. And that will give us the time that we've got a minimum. But then we also need to check that that turning point really is a minimum turning point and it's not a maximum. And this is worth 3 marks, and that's what those 3 marks will be for. Now there's 2 ways you can find this minimum. One of them's much easier than the other, and everybody who did this question actually did it the hard way. Now, the natural inclination is to say, all right, I need to differentiate x. Let's find dx dt. But I can't differentiate it while it's got that surd there, so let's rewrite it. And instead of the surd, we can just change it to the power of half. Now we can use the chain law to differentiate this. We can say we're going to bring a half out the front. We have to differentiate what's in the brackets and also multiply by that. So differentiating what's in the brackets is quite straightforward. We've got 1400t minus 5,000. Then we need to rewrite all of this, but drop the power down by 1. So it's going to go down to minus a half, isn't it? Now you could write all of that out to the power of minus a half, or you could think, well, if it's to the power of minus a half, that's the same as 1 over all of that to the power of a half, isn't it? So you're effectively going to get all of that stuff down here. Plus 10,000 to the power of a half. Now you could write it to the power of a half, or you could go back to saying, well, this is a square root, really. You could put it as a surd, doesn't matter, either way. So that is the first derivative, isn't it? Now what do we want to do with it? we want to let it equal 0. So on my next line, I might write let dx dt equal 0 and then write it out again, but much quicker and easier just to do that. Perhaps at the beginning you could say, as a plan, let's let dx dt equal 0, because then an examiner will see that you found dx dt and let it equal 0 sort of at the same time. Now the first and most obvious thing to do here is to get rid of the fraction by multiplying both sides by the denominator. And as soon as you do that, that denominator will just disappear because 0 multiplied by anything is 0. So on the next line, we're effectively going to have to just have this part. In fact, I'm going to be a little bit cheeky and just rub that bit out. And so we can just pretty much discount that whole section. All right, what will we do next? Well, we could expand brackets, so we've got our terms there, or we could just say, hey, let's just divide both sides by half, or multiply both sides by 2, same thing. And so that will effectively disappear this part. That might be your next line of working. Now we want to just solve this. Let's add 5,000 to both sides. Dividing both sides by 100 makes sense to me, just so the numbers are a lot smaller. And now t is going to be 50 over 14, which obviously we could simplify down to 25 over 7. Now, t is in hours. So we've just found this in hours, and the question said to the nearest minute. So what we need to do now is put 25 over 7 into our calculator, hit the equals button. And now we want to hit the time button, or the degrees, minutes and seconds button, because that will break up the fraction of the hour that we have into minutes and seconds. And that gives me 3 hours, 34 minutes and 17.14 seconds. So that 17 seconds is less than 30. So I round down and we can just say that we've got 3 hours and 34 minutes to the nearest minute. Now, I mentioned that there was an easier way and a harder way to do this question. Even the hard way wasn't really that hard. And again, I suspect that some students will get psyched out a little bit by this just because it's at the end of the paper. So they're expecting it to be harder than it actually was. Differentiating this wasn't really that difficult. But there's an easier way. The easier way is to say, well, look, if I want to make x a minimum, and x is the square root of some stuff, how do we make x be as small as we can? Well, you could make the entire right-hand side of the equation as small as possible. But the way to do that is by making everything inside this square root bracket as small as possible. Okay, how do you make 700t squared minus 5,000t plus 10,000 as small as possible? How do you find its minimum? Well, you can just differentiate that. And then if you do it that way, the working is so much more simple, because you'll say, look, let's differentiate not x, but x squared. Because if x is equal to this, x squared is equal to just the part in the brackets. So let's differentiate x squared with respect to t. Now we're just differentiating the stuff in the brackets. We get our 1400t minus 5,000, and we don't have to worry about all that absurd and rewriting the stuff that's in the brackets raised to the power of half. We're there. So when we let that equal 0, we're just further down the page, and it's just going to be quicker and easier. And spotting quick methods is important if you're running out of time, especially on the last question in the paper. So more than one way to do that one. Looking out for time savers is a good idea. It gives you more time on perhaps some of the tougher questions.